Alright, here we are back with the next video lesson here. This is simplifying radicals. And I have a key concept here. You definitely need to write this down, please. Simplest form of a radical. You need to know what that is, or what does that mean? What it is I'm talking about what your answer has to look like before you turn it in today. The answer has three things that you cannot have in the answer for this to be simplified. The first one, no perfect squares, except one, just the number one, that one's okay, in the radicand. Remember, the radicand is the number inside the radical sign. The second thing that you cannot have in your answer is fractions in the radicand. So underneath the radical sign, no fractions. And the third one, radicals in the denominator of a fraction. No radicals in the denominator. What do I mean by that? Here's a couple examples. The first one, 4 perfect square. No perfect squares. No perfect squares. The second one, no fractions, please, in the radical. No fractions in as the radicand. That would be the radicand. And then the last one, no square root signs or radical signs in the denominator of the answer. So let's see what that looks like. One more key concept here, though, before we get started. It's called the product property of radicals. What is that? Product, product means multiply. So, for instance, if I have an example that said the square root of a and b, I can rewrite it with the product property as square root of a times square root of b, the product. Remember, the product is an answer to a multiplication problem, and so I can rewrite this like this, and we're going to use this a lot in this video. Condition on that right here, where a is greater than or equal to 0, and b is also greater than or equal to 0. So in this particular definition, b is either going to be a 0 or it's going to be greater. No negatives. Kind of nice. Example, let's say, for instance, I wanted you to simplify the square root of 4 times 5. You could go ahead and use the product property and split it up. So you got square root of 4 times square root of 5. And I would get the, I would get the 2 square roots of 5 for my final answer. That would be simplified because it meets all the criteria in the first slide. Remember, 2 came from, what is the square root of 4? Well, that's 2. 2 times 2 is 4. That's where the 2 came from. All right, so here's an example. Simplify the expression. I asked you to simplify the square root of 50. I want you to think factor using perfect square factors. What? I want you to think that what are the perfect squares that you can see in 50? 4 times anything, 50? No. 25 times 2, 25 is a perfect square because 5 times 5 is 25. So I'm going to use 25 times 2. So I'm going to rewrite 50, 25 times 2, underneath the radical sign. And then my next one, I'm going to use the product property, split them up, and I've got the square root of 25 times the square root of 2. And then previously we learned that square root of 25, in fact, is the same as 5. And I'm just going to bring this one down along for the ride. I'm not going to break that down anymore. Remember, I'm allowed to leave if I do not have a perfect square under here, remember, we're allowed to leave the square root sign with that radicand right there. And so that is simplified. 5 square roots of 2. All I did is went from 50. I thought of a perfect square that goes into 50. It's actually, 25 is a factor of that, and worked it out from there. Do another one. Simplify the square root of 48. Some perfect squares that are part of 48. How about 4? 4 times 12, and I'm just bringing it down again, the square root of 4 times 12 Are there any more perfect squares in this scenario? Look at 12. 4 times 3, those are both factors of 12. So another perfect square I can bring out right here, and I can rewrite it. 4 times 4 times 3. I would still have 48 at the top. And now I can take this, and I'm going to rewrite it with the product property and also combining those two 4's. 4 times 4 is the same as writing 4 squared. So the square root sign comes down, square root, 4 squared times, using the product property, the square root of 3. And if you remember previously, a square root with a base and an exponent of 2 underneath it, the square root and the squares, they just cancel out. And that's how I get 4. So the square root of 4 squared is the same thing as pulling out, the 4's. Remember, I need, the index is 2 here. I need a pair of one number multiplied times itself to pull it out. So that's where the 4 comes from. And again, I just leave that alone. That's not a perfect square. I'm just going to leave the square root sign there with it. So what happened? How did I go from here again? I just simplified the square root of 4 squared, which equals 4. And remember, we learned previously that square root of x squared was the same as x. And that's why we did it, so we were able to solve x before. Okay, example number 3. Simplify. Now I have a fraction underneath the radical sign. Well, I'm still going to think about 32. I'm still going to think about some perfect squares that I can bring out of the 32. 4 is 1, 8, 12, 16. 16 is a really nice high perfect square because 4 times 4 is 16. I'm going to use 16. So 2 times 16, which gives me my 32 back if I want. And then this one, we've done this one already, so 2 times 25. And now you'll notice I kept everything underneath the square root sign still. I just turned it into 2 times 16 divided by 2 times 25. And my next step down here, you can see the 2's are gone. The 2's are gone because 2 divided by 2 is 1. So they just canceled out. And we're trying to simplify, so that helped out quite a bit in this particular problem. So now I have the square root of 16 divided by 25. There is another property called the quotient property. Just the opposite of the product property. And instead of, the product property, I was able to split them up this way. Quotient, we're going to split them up this way. We're going to split the radicals up. So I'm going to take this square root sign on top for the numerator. Square root of 16. Big division sign across right there. And the bottom one, the square root of 25. Now I know I can figure that out by itself. The square root of 16 is 4. And then also the square root of 25 is 5. So 4/5 is the answer, or the simplified answer of the square root of 32 over 50. Okay, our last example here, and I really want you to write this one down. This is rationalize the denominator. And I'm going to actually have you, I'd like you to watch this at least twice, maybe 3 times. And watch how the sequence goes through how we rationalize the denominator. Why do we have to do that? Because if I don't rationalize it, I'm not going to meet the criteria in the beginning for a simplified radical. I cannot have that radical sign, down here in my answer. So here's what we're going to do. For an example, I'm going to simplify the square root of 1 over 18. I'm going to use the quotient property to break that up. Square root of 1 divided by the square root of 18. So I went from here to here. And now I'm thinking, any perfect squares that I can pull out of this? And of course, we can pull 9 out. So I rewrite that, square root of 1 divided by the square root of 2 times 9, and I'm going to come down here. square root of 1, I'm just still leaving it alone. And I went ahead and used the product property right there. Now I split those ones up. Square root of 2 times the square root of 9. And now I'm going to simplify the square roots. Remember, the square root of 1 is just 1. 1 times 1 is 1. So I can just drop the square root sign right there. Right here, I have a square root of 2. Not a perfect square, so I'm going to leave the square root sign with the 2. This one, I just need the square root of 9. That's 3. 3 times 3. So I'm allowed to bring it out and make sure that you have the number that you bring out, the constant. He stays on the left side of the radical when we write our answer. So right now I've got 3 square roots of 2 coming from here. 1 divided by 3 square roots of 2. Notice I have a radical in the denominator, and that is a no-go. We're going to have to simplify. We're going to have to do some more work here. So we follow the path up here. 1 divided by 3 square roots of 2. This comes into where we rationalize the denominator. Rationalizing the denominator is nothing more than multiplying the expression right here by whatever the square root sign, whatever the problem that we have. You know, there's a square root sign with a radical or a radicand inside. We're just going to multiply this fraction by this sign for the top and the bottom. Remember, we have to stay balanced. So whatever I do, if I multiply something to the bottom, to the denominator, I got to do the same thing. Why is that? Because look at this. Square root of 2 divided by the square root of 2 is the same as the number 1. I can multiply anything by 1 and not change it. Everything's cool. So we're going to multiply this fraction by the square root of 2 divided by the square root of 2. This came from this square root right here. This is called rationalizing the denominator. So here's the process. Number 1, 1 times the square root of 2 is the square root of 2. 3 times the square root of 2 times the square root of 2 is the same thing as writing 3 times the square root of 2 times the square root of 2. Equals, just bring this over, and on the bottom down here, I'm going to go ahead and reverse the product property. I'm going to put them together under 1 square root sign right there. So now I have 3 square roots of 2 times 2. Come down here, I haven't done anything with him yet. Square root of 2 still stays there, divided by, but I went ahead and combined. I know 2 times 2 is the same thing as 2 squared. So 3 square root of 2 squared, because that square root and that square sign right there, they're going to cancel out. Equals the square root sign here divided by, they're going to cancel out and leave me with 2, so it turns into 3 times 2. Really nice. This comes down here, and my final answer is the square root of 2 divided by 6. That's the simplified answer for this problem. Rationalize the denominator. Right here is where it starts. And again, please read this one. Take some good notes on this one, and I look forward to seeing you in class.